Hello everyone, welcome back to Bytes of CSC. So in this lecture, we'll be talking about the keys of database management system. I'll try to keep the lecture as concise as possible. Now, the first key that we'll be learning about is the super key. Now, let us consider a relational table with attributes, project ID, project name, location allowance, and department code. So this is the project table C. Now, according to your textbook, it says that super key is a set of attributes that can uniquely identify a tuple in a relational table. Now, one important feature of relational table is no two tuples or rows can have the exact same values. Now, for example, say we have two entries in your database table which has the same project ID, project name, location allowance, and department code. So, in this case, the location values of the two rows needs to be different. So if you say that if I take all the attributes of a table, like in this case project ID, project name, location, allowance, and department code, that forms a super key of the table, because that of course uniquely identifies a tuple. Yes, you'll be right, of course, that does make it a super key. But what might be the problem with that? Say all your projects are based in, say, Noida. Now your location column will have this value Noida for all the entries. Now say you delete this attribute location from your set of super key. Will the remaining values like project ID, project name, location allowance, and department code, will these four attributes be able to uniquely identify a tuple? Yes, of course, because all the location and tuples have the same value. So now I hope you understand that super key contains extraneous attribute, like this location in this case, in our example, was that extraneous attribute. Now what can be done about that? So we shifted to another kind of key which is known as a candidate key, which says that it is a minimal set of attributes that uniquely identifies a tuple. Now we are considering the same project table, and if we use a little bit of common sense, we might say that two projects in the same location might not have the same name. So in that case, we can say that project name and location, if we take these two attributes together, these two attributes are sufficient to uniquely identify a column or uniquely identify a tuple in a relational table. Now, what if we remove this location attribute from here? Will that still be able to uniquely identify your tuple? Now, here we are not considering all the projects are based in the same location. So, in that case, no. There might be that two projects have the same name. Probably the same project has been controlled by two different departments, and we have entry for each of those projects. So in that case, your project name will not be sufficient to uniquely identify a tuple in a relationship. And also names are very common, right? So two projects might have the same name. So if you remove an attribute from a candidate key, the remaining attribute will not be able to uniquely identify the tuple. So candidate key does not contain any extraneous attributes. Similarly, we can say that project ID and project name, these two taken together can also uniquely identify a tuple. Or we can also say department code and project name. It's very unlikely, right, that the same department will be controlling two projects with the same name. So yes, we can also say that like this is another candidate key. So basically a relation can have more than one candidate keys, as we have seen right now. Now the question is then, what is a primary key? Now primary key is also an attribute or a set of attributes that uniquely identify a tuple. So primary key is nothing but a candidate key which is selected by the database designer that can uniquely identify a relation. So you can say that, a super key, like if this is your super key, candidate key is a subset of your super key, a proper subset. Sorry, what I'm saying. So this is your candidate key, and well, primary key is also one of the candidate keys of your relation. Now, apart from being a candidate key, if a set of attributes or an attribute has been set to be a primary key, it also mandates that first of all the tuples will have unique value in for those attributes. Those attributes which has been declared as primary key will have unique values, and also you cannot leave the value as blank, so it cannot contain null values. So that also is an interesting point which differs it from the unique key. Now, unique key is an attribute that has a unique value. So if you say that the controlling department has to be unique, like no two department will have the same no department can control more than one project. So you can say that your department code value can be a unique value. You can say like that. So the only difference between a unique key and a primary key is if an attribute has been declared to be a unique key attribute, only one of the values can be null, whereas in primary key, none of the values can be null. In this case, one of the values can be null. So that's the main difference between a unique key and a primary key. And then we move on to foreign key. Now, if you look at this project table, there is this department code attribute, and of course you guessed it right that we have a department table too, which contains details about a particular department. So this department code value in this table actually comes from the department code values that are present in this department table. So now if somebody tries to enter a value into your project table, and by mistake he or she types in a department code, say D0007, that still does not exist in this department table, that would be an error. Like it will be controlled by a department which does not exist. So in order to contain those kind of errors, a foreign key has been introduced. So a foreign key is essentially any attribute, if you declare that to be foreign key, so that attribute actually comes from another table where it is a primary key. Now in this case, now this table where the foreign key has been declared is known as the referencing table. This is your, there would be a key referencing table, and your department table is a referenced table. So a foreign key in the referencing table has to be the primary key in the referenced table. Now if we take an example now, so this is your project table. So you have 3 projects with their controlling department, and these are the departments present in the company. Now one tries to enter a tuple or some values regarding a project, and by mistake he types D06, and D06 is not one of these values in this database table department. So an error will show up, and this value will not be entered into this database table project. Now this also brings us to another important issue, that is, say if department D06 actually exists. So a new department has been opened, and the management has decided, so this department will be coded as D06, but the database, the data entry operator by mistake has not yet entered the details of this department D06 into this table. So now D06 does not officially exist in this particular database table. Now, another entry operator who is not aware of the fact tries to enter the details of a project which is controlled by this D06 department. So he or she will not be able to make any entry to this table since D06 does not occur in this table. So there are some important features of primary key now which has to be considered. Number one, which I said before, that foreign key of the referencing relation is the primary key of the referenced relation. Now, data needs to be inserted in the referenced relation first. So, in order to make an entry of a project, this P006, first, which is controlled by D06 department, first this details regarding this D06 has to be entered into this table first. Then only you can make an entry regarding this project P006 in the projects table. And also there is an important factor, that is on delete cascade. Now say this civil department does not exist anymore. So they have decided to close down this civil department, that is D01. Now we have a project which is linked to this department. Now what is going to be the fate of this project? So in that case, something needs to be done. Otherwise, this department does not exist in this table. So what would be the fate of this particular tuple in the referencing table? So if this on delete cascade has been mentioned, in that case, this all the projects, or in this case P001, will also be deleted automatically from the projects table, because this department code does not exist. Now if you have updated this value to say D007 before deleting this civil department, then it wouldn't have been deleted. But if it contains this department code as D01, and now D01 does not exist in the parent department, in the parent table or the referenced table, that is the department table, any tuple related to this deleted tuple will also be deleted. Now if we take an example, you generally you come across these type of questions in your exams like GATE or NET. Now in this question it says that the following tables has two attributes, A and C. A is the primary key and C is the foreign key that references A with on delete cascade. A set of tables that must be additionally deleted to preserve referential integrity when the tuple 24 is deleted is. Now it says that this is your primary key and this is your foreign key. Now, and this refers this. So yes, this kind of self-reference is also valid in DBMS. So now it says that this tuple is deleted. Now since this tuple is deleted, now all the entry, since this is the primary key, so all the entry where the value of C is 2 needs to be deleted. Now if we go through the table, we have this tuple that needs to be deleted, and this also has got 2 in the C column, so this also has to be deleted. Now next, there are two values 5 and 7 which are the primary key in this table, and if any of these values belong to this C column, those tuples should also be deleted now. Now we do not have any entry related to 7 in this table. See, it's 4, 4, 3, 2, 2, 5 and 4. So that's okay. Now any entry related to 5, yes, we have this tuple which has 5 in the C column. So this tuple also has to be deleted. Now we are left with 9. So now 9 does not feature in any of the list in your C table. So that's all. So we have to delete additionally this tuple 5 2, then 7 2, then 9 5. So your C will be the answer. And now this just sums up whatever I have said. You can take a screenshot of this. So this is in case of a super key, it contains extraneous attribute. It can contain null value. There can be more, the number of keys is, if you can have more than one super key in your relational table, yes, you can have more than one key, as we have shown in that example. If you remove that extraneous attribute, it still remains a super key. And well, this is a special property, like this is just a set of attributes. It doesn't have any special property as such, because this is the general key definition, which says that key is a set of attributes that uniquely identifies a tuple in a relational table. Now if we move on to candidate key, it doesn't contain any extraneous attribute. It can have, some of the candidate keys can have well, null values. It is not totally forbidden that candidate keys cannot have a null value, and there can be a number of candidate keys or a number of set of attributes that can uniquely identify a tuple. And of course, it was a minimal set of attributes that if you remove one of those attributes, the key will no longer be a candidate key. Next, we have primary key, which of course does not contain any extraneous attribute. It cannot have any null value, and there is only one primary key per table, and that is chosen by the designer. So it is a candidate key which is chosen by a designer. And in case of unique key, there is no extraneous attribute, and it can have only one null value. And how many unique keys? Well, that depends on the database designer or the requirement of your system. And then comes the foreign key. There is no point of having an extraneous attribute. And yes, a foreign key cannot have a null value, because a foreign key is a part of the primary key. That is, a foreign key is a primary key of another table. So obviously a primary key cannot be left null. And the number of keys, well, how many foreign keys in a table? Well, that depends again on the system requirement. And this is an important property, that primary key, the foreign key is the primary key of a referenced table. So that's all for today. If you like my video, please give me a thumbs up and share it with your friends.